Hello, chemistry. We're on practice, final part 3 of the problems. So this is working from chapter 9, so you'll need to probably use some little bits and pieces on chapter 9 from the book to do this, as well as a periodic table. So the top 5 when we take the test will actually be a 10-point question, because it's asking you to do 2 things. One, identify what type it is, and the second is to balance it. So let's do the identifications first. When you do the test will be numbered differently. It'll not go up to 150, it'll go up to 155 because of that recalibration. But there's a thing called combination reactions. Combination reactions are when 2 things become 1. So the second one down that I don't have on my board presently, the Mg plus the S, and then becoming MgS. That is a combination reaction because there were 2 things on the left becoming 1. There's a decomposition. Number 3 on the list is a decomposition because there's 1 thing becoming 2. So that's a thing. There is a thing called a single replacement reaction. Single replacement, we have this one, which is number 5 on the paper. You have a single element plus a compound, and then this element nudges out the other element in the compound. So Mg ends up with Cl instead of being alone. H, instead of being with Cl, now it's alone. That's a single replacement. And then the other 2 are double replacement and neutralization, which looks similar. If you want a guaranteed way to identify neutralizations, there's rules in the book in chapter 9 in the neutralization section that you could recap. But if you want about a 90% shot at it, if you produce water, 90% shot, you're at a neutralization, not a double replacement. The basic idea is that H and Va basically switched plots. H was with SO4, Va was with OH. They switched, so Va is with SO4, and the H went with the other O's and H's to make water. If water is made, that's 90% chance neutralization. The other one then on this is double replacement. That's the 4th one down. I didn't put number 2 and number 4 on the board to balance because they're already balanced. So you could either put a big check mark on that, or you could write already balanced, but I don't have those on the board to balance because they are balanced. So the balancing rules amounted to this. They said, 1, make sure you have correct formulas for reactants and products, which for 1 to 5 you do, because I did that. 2, you pick an element to balance. So here I have barium. Bariums are already balanced. Then you look to the polyatomics. That's like sulfate, SO4, the ones we memorized. SO4 is already a match for SO4, so we're good on that. And then it told us to save the H's and O's for last. So if we look at our H's, there's 2 H's here, there's 2 H's there, because the subscript goes with the H's, so a total of 4. For us to make 4 H's over here, I need a 2 there for 2 times 2 to make 4 H's. When I go to look for O's, these don't count because I already got them with sulfate to work. Those don't count because part of sulfate. This O, there's a 2. This O, there's a 2. So we're good. This one, I look at the NAs, and that's a match. I look at the N's, that's a match. I look then to the O's. Here there's 2 plus 2 makes 4. Over here there's 3. That doesn't work. Odd numbers are usually not your friend, so I'll do a 2 there to get me up to 6 oxygens. When I did that, I just made there be 2 sodiums and 2 nitrogens as well, so I need to chase that down. 2 there will make 2 sodiums and 2 nitrogens. And then my oxygen count over here was 6. 2 times 2 is 4, plus 2 more there is 6, and we're good on that. This, I have Mg's look good, Cl's don't. To balance the Cl's, I needed 2. And then I made 2 H's, and I wanted 2 H's, so that one works. When we get to number 115, we have to complete and balance the reaction. When you complete these reactions, you have to be thinking about charges, probably need to think about the periodic table, probably need to think about the polyatomic ions to memorize, like sulfate, phosphate, hypochlorite, all that stuff. So for this, I'm going to do a double replacement move. I have a compound here and I have a compound there. When I draw that up for you, you need to just switch who's with who. So the Ba needs to go with the acetate, but you have to think about the charges. Barium has a charge of 2 because it's in column 2. Acetate has a charge of 1 because we memorized that. So we need to swap the 2 and the 1. So we have 1 of these, 2 of those. For this group to have 2 of those, we need parentheses. Then I'd want to swap the H to go with the OH. We're not going to write that HOH. We're going to write that as H2O. And let me complete all of these, then I'll balance them all. For the next one, we want to do the same kind of thing. Instead of Ca being with Cl, Ca needs to go with phosphate. Calcium has a charge of 2 because it's in column 2. Phosphate's the only one we memorized with a charge of 3. So I need to take 2 and 3 and switch them. So there's 3 and 2. Then my other matchup, I need the H's with the Cl's. It doesn't matter what the subscripts were here. I'm going to only make subscripts based on charges. If I buddy H up with Cl, that just works because H is in column 1, chlorine's in column 7, everything wants 8 electrons, so it also has a charge of 1 to get from 7 to 8, so that just works, doesn't need any subscripts there for HCl. The PB one, the PB, lead, needs to go with chlorine. Lead is tricky because lead has multiple charges. There's 2 different kinds of lead. So nitrate has a charge of 1. There were 2 nitrates present, so that means this lead had to have a charge of 2. Chlorine always has a charge of 1. We just talked about that a second ago. It's in column 7, needs to get to 8, so it has a charge of 1. So with charges of 2s and 1s, I need 1 and 2 of those. And then I need to send the H to go with NO3. It doesn't matter that NO3 used to have a subscript. I have to new and improved think about charge issues here. H has a charge of 1, because it's in column 1. Nitrate we memorized as a charge of 1, so that's good. This, I don't have switches I can do, so this must be a combination reaction. I just need to put Na with Cl. Na has a charge of 1, Cl has a charge of 1, so we're good on that without subscripts. And then this last one might be a single replacement. There's a lonely element, and then there's a compound. Magnesium might squeeze out copper, so what you'd have to look at is a chart from page 228. And when you go to do your test, feel free to use the chart on page 228 and look this up, make a note to yourself, need page 228. On the chart on page 228 in the margin, Mg is higher on the list than Cu. So what that means is that Mg will take Cu's place. Cu will be lonely. Mg will take the place of copper to go with SO4. Mg has a charge of 2. SO4 we memorized has a charge of 2. I know Mg has a charge of 2 because it's in column 2, and you can use a periodic table when you do this test, so I don't need any subscripts on those. Now we need to balance. So for balancing purposes, this is where we are. I'd look barium first, that looks fine. I would look at acetate next. Acetate over here, there's 2 of that group. So here I need to make there be 2 of that group. Oxygen total, here there's 2. I don't have to worry about the O's that are part of acetate. To make there be 2 O's, over there I needed 2. H's, I have 2 H's, and here I have 2 more H's, is 4 H's. I don't care about those because it's part of acetate. That has 4 H's, so I'm good. This, the calciums are out of whack, so I need a 3 there for my calciums to balance. This, I have 2 chlorines, so I need a 2 for my chlorines to balance. Phosphates are out of whack, so I need a 2 there to balance the phosphates. And then I hope for luck on the hydrogens, and I have 6 hydrogens here, and that did not happen. So I need to do a modification to get 6 hydrogens over there. In which case, I have 6 chlorines, 3 calciums, 6 hydrogens, 2 phosphates, and we're good. That balances. Checking off my paper. We're good. I think my crisis there was I don't think I had balanced the chlorines before I looked to do the hydrogens. You always want to save hydrogen and oxygen for last, but I don't think I did that. I'll have to watch an instant replay later and see. This PV one, the PVs look good. The chlorines don't. I need a 2 to balance the chlorines. NO3, there's 2 NO3s here. So now I have 2 NO3s there. That has 2 hydrogens, this has 2 hydrogens, so we're good. Chlorine, there's 2 chlorines, so I need a 2 there to make the chlorines match. I just made 2 sodiums, so 2 there would make the sodiums match. Then for that last one, the Mgs look good, the coppers look good, the SO4s look good, that's already balanced. So somehow put a check mark or write a note like already balanced or something on those, just so I know you didn't skip it, but that you knew that it was already balanced. Then we break out the dimensional analysis. So the dimensional analysis scheme on this group, this chapter was step 1, find the moles of known. Step 2, find the moles of unknown. Step 3, when necessary, find the mass or the volume of the unknown. So I'll do 120, and the rest kind of go like that for a little while. So we start with 76.5 grams of zinc. So the first thing we have to do is figure out the moles of zinc. So we would want to eliminate grams of zinc by having a cancel happen. Start with copying the problem in the first slot. Put grams of zinc to cancel on the bottom. Make moles of zinc. The number for moles is always 1. The number for grams is always from the periodic table. That's going to be 65.4. Then we're going to go and get to the moles of the unknown. So I need, since moles of zinc are on top, I'll cancel that by putting moles of zinc on the bottom. And I'll put the moles of what I asked you for on top, which is moles of zinc chloride, ZnCl2. To do the mole-to-mole numbers, we need to look to the coefficients in the equation, which these have already all been balanced for you. There are none that you have to balance the equations. I cut you a break on that. This particular equation, the coefficients are both 1s, so that's nice. Then we try to go from the moles of this known thing, now, well, unknown, now it's known, but go from moles of ZnCl2 by putting that on the bottom, and get to grams of ZnCl2. The number for moles continues to be 1. The number for ZnCl2 you're going to have to look up on your periodic table. Zinc's number plus 2 of chlorine's numbers, that should get you 136.4, and then you punch it in. 121 is basically the same style of question. Just if you have the key, the 87.9 on the bottom came from the periodic table, just like this did. The 2 on top of 4 came from the coefficients when we went mole to mole. This 159 on the problem 121 is coming from the periodic table, just like this. The only difference on 121 when you get to the end is you need to go from grams to kilograms, and that put 1,000 grams on the bottom. 122 is a little shorter because you were asked for moles. So instead of the problem continuing the whole way to the finish line, it cuts out at this point. So on 122, if you look at my answer key, the 208.3 on the bottom is from the periodic table, and then 1 and 1 we're using the coefficients in the equation. 123 is that a similar length to that. It actually on 123 cuts off a step, it steps in a step down the road. On 123, it starts you with a number of moles. Then we're ready to go from moles to moles. The 4/2 in the mole to mole conversion, those are the coefficients in the equation that I wrote for you. And then there's a 44 grams for 1 mole. That 44 grams came from periodic table from carbon is 12 plus for O2, 2 to the 16th for oxygen is how that adds up to 44. On the back, 124 is the shortest one of this whole group. I start you with moles, and I ask you to get moles of the other one. The only thing you're going to have to use there is just a quick one step with coefficients. There's a 2/2 from the coefficients. 125, 6, 7 is the longest cluster of problems that we do. These go together. These are the limiting reagent problems. So 125, you'd start with 3.4 grams of magnesium. Go from grams to moles as we have it. 1 mole for the top, periodic table for the bottom. That's been the truth for almost all of these questions so far. And then we go from moles to moles. We want to get away from moles at Mg in this case to get moles of hydrogen is where we're trying to get. Mole to mole, we use the coefficients, and in this problem they're all 1s. And I would jot down a 0.1399 right about there. Right here it was also 0.1399 because the 1 to 1 didn't change anything. We'll do another partial start of a question using the 24.6 grams H2SO4. We'll get those grams to moles using a 1. 98.1 is what you get adding up 2 hydrogens plus 1 sulfur plus 4 oxygens on the periodic table. And then to go from moles of H2SO4 to moles of H2, we need the coefficients, but they're all 1s again. This should give me a 0.2508. If I just punched in the first little step, that's what I get. If I punch in the whole step, that's what I get. We have these two numbers to compare to each other. What we do from there is we finish the problem that had the lower number. So since this had the lower number, this is the limiting. That makes this the excess. We finished the problem that had the limiting reagent by going from moles to grams using the periodic table. 1 mole, there's 2 grams because H is a 1 times 2. If you punch this in, this will give you the answer to 125. For 126's answer, you would take the 122 in the problem, divide by 125's answer, and then times 100 to make a percentage, and that's 126. 127, to figure out the excess that's left, we always need to have the moles of limiting. This is limiting. The moles of limiting comes from right here. of 0.1399. We need to cancel moles of limiting and turn that into moles of excess by using the coefficients, which are both 1s, and that'll churn out a 0.1399 moles of excess that got used. This is the moles of excess originally, the 0.2508 from there. Doing 24 dividing 98 got us that number. To figure out what's left, we just have to subtract those, and that'll get you 127. Remember, for all of these answers, to do 3 significant digits and then a unit as well. 128, we're back to just single step problems, more like the earlier ones. So here's 128. 128, start with the number as always that I give you, 1.63 grams FES. Continue to get from grams to moles as we have it. We'll cancel the grams, getting a number from the periodic table. We'd have to add Fe's number plus sulfur's number, and that'll be 87.9. That's always a 1. Then we try to go from moles to moles. So we need to find the coefficient for FES, which is 1. We're trying to turn this into hydrogen sulfide, so we find that, and it has a coefficient of 1. We're always going to use the coefficients for this mole-to-mole step after we've probably used the gram-mole periodic table step. The only difference on this last group is we're trying not to get back to a mass using a periodic table number at the end. We're trying to get to liters using 22.4. But still using 1 mole. Punch that in, that'd be 128. 129 is a step shorter. We don't have to do anything with the grams. On 129, they give you moles to start, and then we'll do the coefficients. For 129, the coefficients would have a 3 over a 2, and then we'll finish with the same 22.4. 130, they start with liters. So let me do that one. They start with 3.42 liters, Cl2. So we'll get from liters to moles. To get rid of liters and get to moles, 22.4 liters gets you to a mole. Then they want us to go from moles of Cl2, so we'll put that on the bottom, to moles of KClO3. We'll need to use the coefficients in the equation. Cl2 has a 3 in the equation, and the KClO3 just has a 1, and we'll punch that in. 131 is the shortest one. If you're going from liters to liters, you don't have to work through moles at all. On my answer key for 131, I wrote moles on top of moles in my work. These should be liters here. I didn't need to do anything with moles. That's just me getting in the rhythm of writing moles all the time. That should just say liters. Start with 4.62 liters NH3. If you want to go from liters to liters, you can also just do that with the coefficients to go from liters to liters. NH3's coefficient is a 2. N2's coefficient is a 1. So we'll just pop that through there. 132. I think I'm just going to put that into video 2 because 132 is more like the problems on the next page. So I'll just save the 132 explanation for next video. We'll build up some momentum and keep going with that. So 132 next time.